All right, so we've walked through some of the basics of finding some of our descriptive statistics and naming our variables. Now let's move on to some of our other elements of statistical analyses. You will want to be able to find a z-score and use that z-score to find outliers. So how do we do this? Let's say I want to look at the z-scores of the current number of work hours, and I want to see if there's any outliers in this. Analyze, descriptive statistics, descriptives. Let's see. I want the current number, the average hour of numbers worked per week. Let's say I want to know the mean, standard deviation, and variance, but I'm also interested down here in saving the z-scores of my selected variables. So I'm going to click OK. So now I know, again, I have my verification that my number of participants was 100. My mean number of numbers worked per week was 21.93. My standard deviation was 13.28. And my variance was 176.39. But now let me come back over here and look at my z-scores. Remember, what value of z-score do you need for something to be an outlier? You can pause me and answer if you need to. It will either be above -3 or above 3 or below -3. So let's start first by looking at the low end, sort descending, or I mean the high end. Let's do sort ascending. So I don't have anything below -3. So I don't have any low outliers. Let's look for high outliers and say sort descending. So here you'll see my highest z-score is 3.47, which would count as an outlier. So I can see that here student number 1434, who is 27 years old, is taking probably one class at a time, 3 credit hours, and is working 68 hours a week. So this participant, this student, would be an outlier. We can also see they scored pretty high on this life stressor scale. Okay, so we would need to then decide, do we keep this participant in or not? But the point being, for the purposes of what I want you to know for the midterm, is using these z-scores we found, we can say, okay, yes, I have an outlier in my data set, and here is what we know about this outlier. And then you could decide what to do with that participant. Now, let's say maybe I want to do something different with my work hours. Maybe I want to see, on average, how many hours is a math major working compared to an education major? Because maybe I'm thinking, you know what, the education majors, they have to do student teaching, they have to do a bunch of stuff. Maybe they're working more hours outside of the classroom than like my math majors or my English majors. So I come over here to analyze, compare means, and means. And remember, this was a little trick that I taught you how to do in one of our other videos. So for my dependent list, the thing that I'm wanting to see broken down is my average hours of numbers worked per week. And my independent list, the categories that I'm wanting to see, is student major. I'm going to click OK. I'm going to come over here to my output. And so I can look and see, okay, on average, my biology majors have a mean of 21.64 hours worked outside of class. Whoops. My education have 24.24, math 24.93, English 27.5. So I can look at my majors and the average number of hours that they work per week, the mean number of hours. So that could just be a handy thing to know for your descriptive statistics. It could end up being relevant if you're trying to explain some differences at the end. All right, let's come back over here to our data. What is next? All right, now let's say, now we're going to get into our different types of tests that you will need to know how to do. So we've done our descriptives. Now, let's say that we want to dive right in and say, we know that we had a pre-test and a post-test of our test anxiety. We want to know, was there any significant difference between the pre-test and the post-test for the group that took the workshop. All right. Now let's remember mathematically what we're doing is our null hypothesis would be there's zero difference. So what we're trying to see is if this difference score is going to be statistically significant than zero. But remember from the walkthrough videos we did earlier, there's an important step we have to do first. Because if we're only wanting to evaluate the students that took the workshop, the students that were in the experimental group, group number 1, we have to tell our software that that's the only one we're analyzing. So we go up here to data, select cases. We don't want all cases. We don't want a random sample of cases. We want to filter our cases based on experimental or control group. And we're going to tell it the unselected cases are filtered out. We don't want to delete them from our data set. We're going to use them later. We just don't need them right now. We're going to click OK. And remember the trick I showed you. You can look right down here and see that it worked and your filter's on. And you can also check your little crosshatches here and see that the ones that are crossed out are the 0 group. The ones that are active are your 1 group. So now we're all set up to ask, is there a difference in the score between pretest and post-test? I want you to pause me and answer, which type of test do we use for this? We use a t-test for dependent means, which remember, our program, our PSPP, is going to call this a paired samples t-test. And this makes logical sense, right? A t-test for dependent means the significance of their score on their post-test anxiety is dependent on their score of their pretest for test anxiety. And this is a pair of samples. They go together. It doesn't really help me out to compare the pretest of student 1434 with the post-test of student 6824. I want to keep them as a pair. So I'm going to come over here and I'm going to tell it. And remember, when you first open it, your window might look like this. Make sure you spread it out so you can see 1 and 2. I'm going to say that pretest is variable 1. I'm going to say that post-test is variable 2. Remember, I don't need any of these options right now. And I'm going to click OK. I'm going to open my output. And now I'm going to decide what do I do with this information, right? So I can see the test anxiety on the pretest for these 52 students that were in my experimental group was 63.19 with a standard deviation of 23.62. I can see that the scores of the post-test test anxiety for these same 52 students was 31.63 with a standard deviation of 21.2. Now I can look at this and say, okay, so the mean score dropped a lot from pretest to post-test. But now I need to actually look at the statistical analyses to see, was this statistically significantly different? My t-score is 7.45 with 51 degrees of freedom, right? 52 minus 1 gives me this 51. And my significance is so much, like it's below even that 0.001 cutoff, right? Like we have a few more zeros in front of our 1. So I know that this was statistically significant. The likelihood that this result was achieved based on coincidence, we are now at less than 1 in, what would it be, 1 in 1,000, 1 in 10,000, because we don't even have a 1 over here. We don't know how many more zeros we would need to go out to get to our 1. So we can say with pretty good confidence, okay, our workshop made a statistically significant difference in our students' levels of test anxiety. But now let's look at a couple more things. Maybe we wanted to make the argument of, well, you know what? Okay, so we had a significant difference at the end, but maybe all students would get lower test anxiety throughout the year as they take more and more tests, right? Everybody gets more used to taking tests. Maybe that naturally would reduce. So in that case, what we would want to do is we would want to compare our test anxiety post scores after the workshop between the students who had the workshop and the students who didn't. Because if the students that had the workshop had much, much lower test anxiety compared to the beginning of the year, or actually not compared to the beginning of the year, totally forget I said that. If at the end of the semester, the students who took the workshop had a similar level of test anxiety to the students who didn't, then we would know that maybe something else was going on. But if at the end of the year, the students that had the workshop had a significantly lower level of test anxiety than the students who didn't have the workshop, then that would give us one more piece of evidence that, okay, our workshop was doing something. So first, what is our first step in doing this? Because if pay attention to these details, we have a problem right now, right? We still have our select cases on. So we need to make sure to come up here to data and fix this and let it know, okay, now we want all of our cases again. We click OK. We see our crosshatches are gone and we're back over here to all of our filters and weights being off. So we're good to go. So what test do we want to use to say, is there a difference between group 1 and group 0 on this test anxiety post-test score that we did? What is our test? I want you to pause me and answer out loud. We're going to do a t-test for independent means. And remember, this is going to call this an independent samples t-test. We're saying, I want to compare these two groups, right? I want to do the t-test thing that lets me compare two groups, but they're not dependent on each other. The scores in the post-test of the control group don't have anything to do with the scores in the post-test of the experimental group. So I'm doing an independent samples t-test, or as your textbook referred to it, a t-test for independent means. So I'm going to come over here and I'm going to tell it, and clear all this out, because remember, it'll always remember your last selection. I'm going to come over here and I'm going to tell it, what am I wanting to test? What do I want to know the information about? I want to know the information about the test anxiety post-test score. And I'm going to say, I want to group this. I want you to break this down for me based on they were in the experimental group and control group. I'm going to come over here to define my groups. Group 1 is my control group. Group 2 is my experimental group. And I'm going to continue. Let's say maybe I want one more piece of information. Let's say I want to ask, you know what, while we're at it, is there a difference in the way that the students scored at the life stressors scale at the end of the semester? Maybe just by coincidence, one of these groups of students was under more stress than another. So I can plop a second one over here and click OK. Come down here to my output. So it's giving me both of these together because I asked it to do that. All right. So I'm showing my consistent numbers, which I always want to see. There's 48 in the control group, 52 in the experimental group, right? And this matches what we saw up here. Because remember, it's going to save your output as you go down. So let's look at this test anxiety first. The mean of my control group was 35. The mean of my experimental group was 31. The control group had a standard deviation of 17.79. The experimental group had a standard deviation of 21.20. So now looking at this, I can say, all right, it looks like the group that did the class, the workshop, ended up with a little bit lower of a mean score of test anxiety. So let's come see if this was statistically significant. We come over here. Since this is not significant, we use the first line. We trace it all the way over here. So what do we see? Our t-value is 0.86. Our degree of freedom was 98. And we do not have statistical significance, 0.394. So we have to say, all right, we saw there was a difference up here between anxiety pre-test and post-test, but there is not a difference between our experimental group and our control group on levels of test anxiety at the end of the semester. There is no statistically significant difference between these groups. And we're pretty far away, right? We're not even right there on the edge of like being 0.07, where we could say, well, maybe if I had a few more participants in my study, it would work. We're quite a bit off. So then we could start looking for some other explanations, like, well, maybe people naturally reduce test anxiety throughout the semester. But keep in mind, in order to say our two groups are different in a meaningful way, we need this to be our 0.05 or lower. And now let's look at our life stressor scores. We're going to compare it the same way. Control group experimental, 48.04 to 54.83. We're going to come down here. We're not statistically significant, so we can use this first column. And again, we do not have any statistical significance. So there was no major difference in life stressors based on if they were in the experimental group or the control group. Now let's do one more thing, because there's one more thing I'm going to ask you to do on the final, or on the midterm, I mean. So we've compared these groups, but let's say someone from the university came over and said, you know what? We actually gave our entire student population this test anxiety pretest at the beginning of the year, because we wanted to know how many of our students have a problem with test anxiety. So we actually have a mean that we could give you of our current university population. What is the mean score on this test anxiety inventory? Would you just compare and make sure that the group that was selected for your study wasn't statistically significantly different from all of our students when it comes to this test anxiety mean? So we're going to compare the test anxiety pretest from our sample of 100 students to a known population mean. Okay, so pause me and think about, what test are we going to do? We are going to do a one sample t-test, right? Because we have one sample that we're comparing to a population. We're no longer comparing two samples. We're comparing one sample to a population. So compare means, one sample t-test. We are interested in knowing about test anxiety pretest. And let's say that they told us that the mean average for the student population was 75. We got a group with high test anxiety this year, right? And let's click OK. We're going to come over here to our output, and we are going to say our group had a mean of 56.15 with a standard deviation of 25.98. So if we're comparing that to 75, we have a t-score of negative 7.26, 99 degrees of freedom, right? 100 minus 1. And we see that we do have statistical significance. So now this could introduce a problem in our study, right? Because if this number was not statistically significant, then we could say, all right, there was no difference between our groups. It's all the same. Our sample is representative of our population. Here we go. However, the fact that we have statistical significance, this means, all right, going into the study from the beginning, our sample that ended up being chosen for this study was statistically significantly different than the university population when it came to this thing that we're interested in studying, test anxiety. So then, your research team would have to figure out what you do with that. However, make sure you're aware that if you want to say the groups were the same, there's no difference starting out, you want to see this number not being statistically significant. And that's it. Watch this video as many times as you need to. I gave you this exact data set that you can download and you can work along with me. Pause me as much as you need to, work it out. You can save these outputs and take notes about what I said. If you can do all this, the midterm is going to be an absolute breeze. That's all it is. There's nothing tricky. There's no trick questions. I left nothing out. So there you go. Please, please, please email me if you have any questions. I am happy to help. Best of luck.